that's a thing. Okay, I think we're good to go. So does anybody know what we're talking about today? Yeah. How'd you know? It's a bit of a softball to start off the day. Yeah, we're going to talk about, this is kind of two lectures, two half lectures. Well, two full lectures, but they're half length. Errors and promises, I don't want to draw too much of a parallel between them. We're going to talk about how error handling with promises is a little different than normal error handling. But basically, they're two separate parts, so don't get those two concepts entangled. We're going to talk about errors for a bit, take a break, and then switch over to promises. So usually I do a lot of the typing and the talking for this lecture. I'm going to do one of those today, and I'm going to need a little bit of crowdsourced help for the second part. So I'm going to be asking for a little help up here, if anyone's keen to volunteer. Speaking of, is anyone keen to volunteer? Thank you. Come on up. It's not going to be just you up here the whole time, so. Great. So who's experienced an error before? I think people who haven't experienced errors are people who haven't tried programming yet. I don't think there's a single person who has done 10 minutes of programming and not encountered an error. They come up in a lot of places. What's your name? Seth? Okay, Seth is going to create an error for us. So go on. Interesting. I was going to talk about JavaScript errors, but let's talk about Bash errors. So yeah, you can get errors in all sorts of places, right? This is, rather than the node interpreter complaining, this is our shell complaining. It has a certain syntax, right? It thinks your first token is going to be a command. And if it's not, if it turns out that it looks for that command and doesn't find it, it goes like, that's not a valid command, right? There are other circumstances where this particular string of characters would work, like in a string, for example. But the language has expectations about what's wrong. Now, Bash errors kind of suck. They're a bit esoteric in a lot of cases. And I hope that the errors that we write today are going to be better than that. So how about pop into the node REPL? Excellent. Let's create an error here. Any error you want. Just pick your favorite error and make it come up. Whoa. Try again.
You want to come up here?
Sure, yeah. So create an array, treat it as an object by JSON stringifying. Okay, give that a shot. Yeah, exactly. We're going to talk about that in a second. But first, let's take a look at this beautiful error that I've never thought to use in this lecture. So that's really interesting. Let's break this down a bit. Reference error, invalid, left-hand side in assignment. How do we break that down? Reference error is a type of error. Very good. Yeah, so JavaScript, and I'm reluctant to say most programming languages, but many programming languages will give you a type when you get an error. It'll say this is a particular type of thing that went wrong. The interpreter is very good for that with a small subset of errors. Going forward, if you're writing, you don't do this a lot with like application software, but if you're writing like library software or something, you might find yourself writing your own custom errors that have their own plan for describing what's going on, kind of doing some like metaprogramming on the interpreter state to figure out like, oh, a variable called this did this thing wrong, and like I was able to figure that out because I'm like specially designed to notice this problem. I'm the error in that sentence. So reference error refers to what in JavaScript? What's a reference? The value, yeah, there's a problem with what's on the left side, right? Does that check out with what we know about JavaScript? Yeah, so what's the rule that we're violating here? Sorry? One more time? Oh. Not exactly. Not exactly. Can you declare a number as a variable? No. You can have a number in a variable name, but a variable can't start with a number. So one thing I always recommend to people is to go ahead and just look at the JavaScript spec. There's a spec out there that just describes like if you were going to break out some C++ code and write a JavaScript interpreter, this is what it needs to do to be like considered a valid JavaScript interpreter. You can go read that spec, and it says stuff like, it breaks down like, here are the 3 bullet points, that like the flashcard size thing you need to know about what a legal variable name is. I don't think I know exhaustively what the rules are, but one of them is that it has to start with a letter. You can have a number in it. Oh, it can start with a letter or an underscore. Yeah, I think that's the rule. So we violated that here. I think if we try to access a variable that we haven't declared yet, like valid variable name, but we haven't assigned it to anything, I think that gives us a reference error too. Let's give that a try. Well, without declaring a variable, let's just say we haven't varred anything, and we just try to access a variable called foo or whatever. Word of your choice. Potato. Potato, reference error. Potato is not defined. Right? So we use variables to take values and give them names so that we can refer to them later, right? So we can reference them. So we get a reference error that means something has gone wrong with how we tell JavaScript, when I ask for this, this is the thing I want, right? So this is one category of error that is good for us to understand. We don't create reference errors ourselves, except in this sense. Our code can result in reference errors. But they're pretty important to understand, and so noticing this property that they have where the first word is like the type of error can be really useful when you're debugging so that you can narrow the scope. Debugging is all about narrowing the scope. And once you find the right place to look, a lot of bugs reveal themselves once the scope is sufficiently narrowed. So what other kind of interpreter errors can we get? Let's try some stuff. I'm having fun with this. Let's help Seth out here. Yeah, so in this case, it's still a reference error because before JavaScript has a chance to notice that potato is not a function, it notices that potato isn't like a thing that we've given a name to, right? So maybe we can solve the first thing to get the second thing to come up. So make potato a variable. Not quite.
Oh, wait, I'm stupid. Sorry.
It's early. Yeah, so potato, we want potato to be the name of a variable, and the value doesn't really matter, right? Except for the thing that you suggested, it can't really be a function, or it would kind of defeat the purpose. Sure, perfect. Now when we try to invoke potato as a function, type error, nice. Okay, so what might we think about what a type error is as differentiated from a reference error? Pardon me? It's the wrong type. Yeah, type errors usually refer to the wrong type. What does wrongness refer to in this case? Mm-hmm. Looking for a function or trying to use it as a function, but it's not a function, right? So type error usually refers to you, the developer, seem to think that this is a particular thing, and I know that because you tried to invoke it as a function, for example. But you can't do that with this data type. It turned out that when I went and looked at what potato is, it's not the sort of thing you can invoke, right? So type error says, usually what it communicates to you is that you have a value in a variable you're using that isn't what you think it is. Can anyone think of a second way to bring up a type error? Maybe you want quotes around banana.
When you try to make one error, another one comes up.
It's kind of funny that that's a syntax error. I never noticed that before. Sure. Now if we try to reassign waffle, what happens?
Running out of fruits.
There are lots of fruits. We're not going to run out of fruits. So that's interesting. Is it different if you do the same thing but drop the const? Yeah, so that's kind of interesting. Let's talk about that for a second. So we've seen reference errors, we've seen syntax errors, we've seen type errors, and now we've seen also type errors. I thought I had a fourth one, but I didn't.
Would it change if we made it let instead of const?
Would it change if we made it let instead of const? What would happen if we made it let? Try to change it to a number. Yeah, so JavaScript's happy to do that. Right? Some languages are not, right? Like a strongly typed language will complain if you say, I have a variable, it's going to be a string. You put a string in and then try to change it to a number. A strongly typed language will complain. Or like not compile or anything, or something. But JavaScript is remarkably happy. In preparing this lecture, I'm like, oh, I'll use this as an example. No, JavaScript just rolls with that. It does a dumb thing, but it just rolls with that. And we're going to look at that a little bit later. But yeah, in this case, JavaScript's just happy to be like, oh, that's a number now? Okay. Weakly typed, dynamically typed. What happens if we do let apple? Okay. So that's a syntax error that's similar to up above when we did const waffle as opposed to just waffle, right? So let allows us to do reassignment, const doesn't. But in either case, it doesn't let us double declare, right? And it's so strongly opinionated about that that it actually considers it a syntax error. Like, you're allowed to touch that variable, but you just must, it must be a typo that there's a const here. So that's kind of interesting. Thank you, Seth. Appreciate that. So that's one type of error that we can get is interpreter errors, right? There are a few other types of errors that we're going to look at. Interpreter errors are, in a way, they're very useful, but in a way they're like the most boring kind of error, right? What are some other kind of errors that we can see come up? Runtime errors? Yep. Runtime errors come from the interpreter, so I have to think about that for a sec if I think those are the same thing. I think those are the same thing. No, I changed my mind. Runtime errors are a bigger category. So yes, interesting. Yeah. Good answer. What other kind of errors can you get? Just throw some ideas out here. Sorry? Port already in use. Okay, what kind of error is that? Yep. Yep. So your port is already in use. You try to like load a server while a server is already running. You run into problems if you're not handling that properly. And like at what layer does that error come up? It's not the interpreter. The interpreter doesn't care about ports, right? It's not your application. Your application barely knows about ports, right? It's something in the middle. So that error probably comes from a library, right? So often when we get errors coming up, like jQuery gives us an error, it's a jQuery error. Someone who worked on the jQuery library decided, if things go wrong in this particular way, this is how I want to inform the user, right? So library developers, mature, well thought out libraries have good errors where the interpreter will allow you to do something, but the library won't. Or the library will have a plan for making things fail in a way that helps out the developer and helps out the stability of the application in some cases. But yeah, those are all errors that have nothing to do with whether or not your JavaScript is okay, right? They have to do with whether or not there's like some kind of application level problem with what you're doing, right? So those are library errors. Any other ideas for error types? Library errors are a type of runtime error because they happen at runtime. Fatal error. Okay, interesting. Yeah, so fatal can mean a lot of things, right? Well, fatal means one thing in particular. Okay, so when you read or write a file, and you can have like permission errors or something. Sure, yeah, you can have like you might, depending on what layer you get that, like if it's in a JavaScript script, you might call that like a file system error or an operating system error. Yeah, so that's the thing that can come up for sure, which is kind of related to the port error. So if I flip over to my text editor here, that's interesting. I didn't know it did that. I get this big ugly red dot. Actually, it's a fine red dot. I'm sorry, dot. Red underline. What does this mean? Yeah. Does that look like an error? that feel like an error? Yeah. What kind of error is this? It's a well, no, it's not a reference error, because a reference error is a runtime error, right? This is the code at rest. This isn't the code while it's running. So you're right that if I ran this, the error that I would get would be a reference error. But this is really just the code that I've written and not run is known by my text editor somehow to have a problem. And it's warning me about that. It's giving me an error. It's not an interpreter error. I can try. How's that? Cool. It's probably going to be a reference error when we run it. So this code is wrong for the same reason that we saw in the REPL when we tried to do something before we declared it, right? But where this error comes from, where this foo is not defined, no undef thing comes from, is somewhere different. So I heard compile error, and one other thing, lint error. So it turns out it's a linter error. And there's a hint down here in like the tiniest font. ESLint. What's the ES mean? ECMAScript, yeah. And yeah, it tells me I don't know how well you can see all this, but I have an error. It comes from ESLint. It tells me what the error is, right? And I think if I go over here, yeah, I get a line number. So you said compile error. This is lint errors are kind of like compile errors in the sense that in a compiled language you can do static analysis on the code. So while the code is compiling, it's getting like changed from the human readable-ish code that a developer wrote into some machine code that is not very readable, but hopefully runs quickly. And during that process, the compiler can notice like, oh yeah, heads up, this isn't going to work. It just fails. So the code never runs. It doesn't crash at runtime. The compiler catches it. So one of the results of that is that you can just do that static analysis in the text editor. So compiled languages have some really cool capabilities when it comes to letting you know what's going to happen with your code before you run it. But a linter works a little different. It does the same kind of, similar kind of static analysis, but when the code runs, the linter doesn't know anything about that. The linter is totally separated from the code actually running, right? Show of hands, who's using a linter? Yeah, cool. That's good. That's good. So yeah, lint errors are another type of error. They don't occur at runtime. They don't come from JavaScript. They come from some other piece of software that gives you lint errors. So is that a good thing or a bad thing that we get lint errors? Good thing. Does anyone think it's a bad thing? Does anyone think errors are a bad thing? Okay, what's the pitch for why errors are a good thing? Errors tell you what you're doing wrong. Yeah, yeah. So it used to be the case in computer programming that you wouldn't get errors, but your code still wouldn't work, right? So a lot of the time, what would happen would be that your code just comes out gibberish. Like you feed like a punch card into a machine, and then you get out like a readout of what happened, and it's just garbage. It's like not even like alphanumeric characters necessarily. It's just like a mess, and you're like, oh, something went wrong. And you have to do like all sorts of like arcane analysis to try to figure out exactly what was wrong and comb through your code yourself. It was a terrible way to do things because you would always find, oh, it's just this one thing right here. Yeah, it's just this one obvious thing. Like as soon as you narrow the scope sufficiently, you're like, oh, that's what's wrong. So errors are good because they help us narrow the scope of what's wrong. So in such a permissive language as JavaScript, where you can do things like divide 1 by 0, and JavaScript's like, okay. Where you can like add an array to a string. What does that do, by the way? It'll just become string, yeah, yeah. So what can we call the plus sign operator here in this case? If that's true, yeah, this is a concatenation operator, right? And one of JavaScript's plans for when you have two different types interacting is, well, just make them both strings. So you can do stuff like this, but in a lot of cases, you wouldn't want to. Like if any developer who was looking at what was going on was like, whoa, 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 you're not expecting that to be an array, are you? That's supposed to be a string. This is a mistake. But JavaScript is cool with JavaScript's like, yeah, okay, yeah, I can figure out something to do with that, right? So having useful, informative, precise errors helps us notice when things like that are going wrong and catch the right thing at the right spot so we don't have to comb through all of our code. It really narrows the field for what could be wrong. And if we're lucky, it tells us exactly what's wrong, right? So I'm going to need another volunteer. So I want to step up. Thank you. Okay, so I have some code here, and I'm going to see if I can make it small enough to fit the whole thing on the screen. Yeah, is that okay? Can you all still read that in the back? Okay, I want to just take a second. Just want everybody to take a second and think about what this code looks like it does. Is there anything baffling here? Is there anything that is really like, is there anything that's really like, I don't know what's going on here and that makes it hard to think about the rest? Okay, line 17. Okay, yeah, that's kind of spooky. And you're saying something about the score? Okay, which, sorry? Uh, the function on line 7 is returning an object? Yeah, yeah, yeah. Yeah. Yeah, okay, so we have a few spooky things going on. So there's something weird about this guy here. Okay. Okay. And there's something weird going on down here. Right. Okay. So not this one? Okay. Yeah. So yeah. So if you get tripped up on anything, it's probably this thing. or it's this thing, and neither of these have anything to do with errors or promises, but let's talk about them because they're cool. And then I thought this thing, line 1, was a little weird too, but maybe it's the kind of weird that you're already used to. And does anyone not know what's going on up there? Okay. Okay, so what's going on down here is this is called the spread operator. Actually, maybe here it's called the rest operator. I don't know, it's either the spread or the rest operator, and I always get confused about which one you use when, because they kind of do the same thing. And they both use like the ... syntax. So what this says is I want to make a new object. I want it to have an attribute called score, and I want that to be the return value of this function. Right? So I'm actually like invoking a function here and getting a return value. Right? This will evaluate to what comes out of the function, not the function itself. And then here what I'm saying is, and then I want you to take all the keys in here and make them keys in here and give them all the values that they have in here. So basically like take all of the things in this object and copy them to this object. So that's a cool way to do things like take an object as is and then modify certain parts of it or add things to it. And that's what I mean by decorate. Is that a word that anyone's familiar with in like a programming context? Okay. Decorate usually means like add something to. Add functionality to, or add data or metadata to. So like you often have functions that you want to report. You want to report the result of the function to like some logging software. So you decorate the function with a logger so that like when you just use the function like normal, but it has the additional functionality of logging something. In this case, I'm taking posts. I'm saying I want to derive from posts, from each post, its score from data that already exists, and decorate the post object with the score. That's what's going on there. On line 17, does anyone want to take a crack at what's going on here? Yeah, is it destructuring? Yeah, it's like you're building stuff backwards. Never heard it put that way before, but I like that. Yeah, so this is object destructuring. Do you want to expand on what that means? You define how a thing is like, and then you build it the opposite way. Kinda, yeah. It's like you can. I've seen on menus in like bougie restaurants like destructured sandwiches or something. Like, and like basically what it is you have like a sandwich, and you don't really think too hard about what's in the sandwich, right? You're like, yeah, it's a sandwich. Like I know what's in it. I saw on the menu, but like I identify this thing as a sandwich. With a destructured sandwich, it's like no, you have like the meat over here and the guac over here and like the mayo in a little dish. It comes like it's like you take the sandwich and you open it up and take the different parts out of it, and treat them as separate things, right? So what's going on here is we have a post, and then we expect the post to have a key called upvotes and a key called downvotes, and this just says I want the upvotes key to be placed in a variable called upvotes, and the downvotes key to be placed in a variable called downvotes. So now instead of going post.upvotes minus post.downvotes, I can just go upvotes minus downvotes. And in this case, that's not like, the payoff here isn't that great. But one of the benefits of this is that it kind of clarifies my intent here that this function deals with these data, And so a post needs to have this interface, and if it doesn't, then it's a problem, right? So it's a way to communicate my intent. These are the variables that I need a post to have. So I can just pass a post. I don't need to know what the post. The caller here doesn't need to know that it's upvotes and downvotes. It just needs to know that it's a post. But down here, I'm communicating that what this function's about is upvotes and downvotes. Okay? Yeah, good question. So would this just be populated with upvotes and downvotes? The answer is it would be populated with whatever comes with a post. Right. And we don't know what that is, right? Yeah. Could we find that out somehow? I was hoping someone would ask that. Yeah, like we don't know what our data looks like, right? We know some stuff about how we're going to work with the data, and we can make some assumptions about it, but we don't actually know what the data looks like. Right? And that's kind of cool that this post can contain all sorts of things. It can have like nested comments. It can have like the body and title of the post. It can have all sorts of things, and we don't really need to know about it. This whole script that figures out upvotes and downvotes just has to know that posts have upvotes and downvotes, and from that you can get the score. So it's like this nice isolation plan when you write your code this way. But yeah, if we wanted to see what the actual data is, well, we could either like log it up here somewhere, or we could just go look at that file, right? So yeah, we might do that, because what we're going to do is like go through this code and improve it. So I think a good place to start is let's run it and see what happens. Yes, please. Okay. So you're going to have to go to my terminal. There it is. You're going to have to quit the REPL. Yeah. Control C. No worries. And this file is called demo-errors.js. So what do we notice? It's an array of objects. Good start. Yeah, there's something weird going on down here, right? Where downvotes is an array. Is there anything else weird about this object? Or these objects, I should say? What's that? One's missing upvotes. Yeah, yeah. Yeah, and we have a couple of them are not a number, right? That's kind of weird. Yeah, you mean the JSON file with the data? Yeah, so it looks a little bit like this is test data. Maybe this data has been like specially designed by a developer to break down, right? So yeah, basically we have some problems with this data, right? So let's look at it this way. Did we get any errors? No. Did we get what we wanted from the function here? Did it do the right thing? Technically? What does technically mean? It did what it was told to do, yeah. But did it do the right thing? Did it do the thing we wanted it to do? Yeah, exactly. So happy path, right? Golden path. It seems to do the right thing, right? 40 up votes, 10 down votes. You expect the score to be 30, you can just eyeball that. And that looks fine, right? Then there are a bunch of circumstances where it doesn't work, right? But we didn't get any errors. The code didn't work, but we didn't get any errors. Kind of. I'm gonna make a brief aside to talk about not a number. We kind of did get an error. Not a number has history in computer science of being this value, like when people were, putting their punch cards into these machines and getting out gibberish on their printers and going, what? One of the earliest solutions to that was to develop not a number. So not a number is a particular bit pattern that basically tells you if you wind up with this, something's gone wrong. Like the whole it doesn't make sense to continue doing operations on this value. Like something has just gone weird. It's like a breeze blew by and like flipped a bunch of bits, and we don't know what's going on anymore. Okay, so not a number is kind of like a primitive like proto error before there was really error handling. And languages like JavaScript inherited it from languages like Java, which inherited it from languages like C. So when you see not a number, like there's really never a time that you're glad to see not a number. That almost always means that something's gone wrong. So if you see that come up, it's almost like getting an error, except JavaScript just passes it along like a value. But yeah, this code seems to work fine in the sense that nothing blew up, right? That's kind of bad. Because while we're developing it, what we want is to know, like if that bad data goes in and the operation can't be completed, we want to know about it. And optionally, we want a way to handle it. So we're going to write some errors. Yeah, so let's flip back to here. So the changes that we want to make to this code don't have anything to do with calculating a score, really. I don't think any of the code in this file really needs to change, but we do want to add some things. We want to add some things so that we can figure out what's going wrong more easily, and we want to add changes so that future developers who are using this code but have never looked at it have a better shot at understanding what's going wrong, right? Does anyone want to pitch an idea about how we might do that? Line 17. Yeah, what about it? Okay, so if post has a missing field, one of these fields is missing. Or the field is not a number like an array, yeah. Then we can set a default. Yeah, that's cool, that's a good idea. But notice that what you're doing is you're building in some logic. You're building in a new decision that wasn't there before, right? You're deciding that the way that we handle bad data is to just pretend that it's zero, right? And that is an option. Often you will do that kind of thing in practice. But I want to talk about errors. So what I want to happen here is I want this app to explode when things go wrong. It's a good idea for a different lecture. Yeah, yeah.
I'm thinking like we could use like two if statements or just one. Say like for example, then you should, instead of returning upvote minus downvote, you should be returning, should be console logging, saying like,
Okay. Okay, so in compute post score, all the posts are going to run through compute post score, and if something goes pear shaped, that's where it's going to happen. So if we check the type of upvotes and downvotes individually, and one of them is the wrong type, then we can log something to the console, thereby informing the developer, who might be you, what's going wrong, and that'll give them insight. That'll help them narrow the field and figure out what the problem is. Good idea. Let's do that. Yeah, man.
okay. Okay, I thought I'll be like full flush the type, but if type of,
Or we could use type of, yeah.
that'll be better, I think.
Yeah, I think type of is a good plan in this case.
I forget the syntax.
Just lowercase type of. And space, variable name.
Oh, space.
Yep. Yeah, type of is like a special, like type of is special. Yeah.
Or we will do the negative logic first, because we want it to not short circuit if it's correct. So what do we want to return? Should we console log it? Huh? I got type it. Oh yeah. Is there anything else?
Yeah, so two things. Type of gives you back a string, so you're comparing the result of type of to a string. Also, JavaScript doesn't have integers.
Right. Sorry, I got probably confused. What was it again?
Just number.
Number. Okay.
JavaScript's like, yeah, keep it simple. Oh, weird. Yeah. Yeah. Yeah, so, okay. So how do you write a good error message? Right? That's where we're at. That's where I wanted to get to. How do you write a good error message? Be descriptive, be concise. Yeah, there's kind of a tension between those two things, right? How do you be descriptive and concise? There are a few things that you want to get into your error message. And how verbose you are, how explicit you are is kind of a case-by-case thing, and your company might have like ideas around like a more formal pattern for your errors. But in general, you want it to contain three things. Does anyone know what they are?
I'm not gonna say anything.
The line or the function, yep. Where in the code the error happened. What data was involved, and why the error was thrown. Or what the problem was, right? So we want to say where the problem happened, right? So that needs to go in the message. And part of that is built into how errors work, but this is just a console log, right? Yeah, you probably don't want to say this occurred on line 18 for a couple reasons. at runtime, you can kind of count on like the line number, like in the stack trace, it gives you a line number. That works out fine. But yeah, I mean, like this code could move around, or it could go through like a compiler or something, a transpiler, and it could get like squished or blown up or all sorts of things. But you might say the function name. Yeah, that sounds fine. So we'll call that plenty good for now for where in the code the error happened. We need what data was involved. And we still need what the problem was. So it's upvote and downvote. That's true. That's kind of incidentally true, but I don't want to think of it that way because in reality, post could have like a bunch of properties. I do want to focus on upvotes and downvotes here. So yeah, the problem is that upvotes and downvotes both need to be numbers, and at least one of them's not. Yeah. So I would phrase that as upvotes and downvotes must both be numbers. That's how I would put that. And then a thumbs down emoji, yeah, that's really important. You could put line breaks in there, yeah. Yeah, so you could use like template strings and then just write it like a normal, like just line breaks will be line breaks. Or you can use like the \n. There's one more thing that we want in here, right? Imagine, what's that? The why. The why is that they both have to be numbers, and implicitly, like one of them's not, right? So you see this error come up. You're like, both have to be numbers. What? They're not numbers? What's the next question you're going to ask? What are they? Yeah. Exactly. What are they? So what data was involved, right? Yeah, like a template string with interpolation. Yeah. You got to use the backticks. You got it. I would just go with the value. It's not crazy to give the type. I wasn't going to say anything, but I would just give the value. Let the developer look at it.
Just the value? Okay. Good.
Yeah.
Okay. I'm used to having them look a little different.
I don't even know why I have those macros. I never use them. Yeah. Yeah, with backticks you can just like do new lines.
Oh, but when I'm console logging it, I don't want it to be next to each other, right?
I don't know. It's kind of up to you. It's a taste thing. Yeah, and we want the value of downvotes too. Cool. So now if we get anything that is not a number in our data, it should blow up. It's a good idea to break there or keep running. Good question. The answer, as usual, is it depends. So yeah, you as a developer have to make a decision about like, okay, so if this happens, what do we do? Do we just pull the fire alarm, or do we just cope and keep on going, right? So that's up to you. It's hard to make a decision, but we'll talk a little bit about how to implement the decision you make after we try this code. Let's see if it works. What is that red dot? That's a lint error. And maybe you can read what the lint error says, even though no one else can.
Error then yes let unexpected console state no console.
Yeah, so I have a lint rule that says you're not allowed to have console logs in your code. This is a good rule for two reasons. One is because if there's a console log in my code, it's always by accident. It's always like I was going around shining a flashlight. Console log is my flashlight. Looking at stuff like what's this, and then I pushed my code and I forgot to take it out. The second reason is because if I do want something to log to the console, I don't use console log. So in my code, I would change that to, before I pushed, I would change that to console warn. Yeah, or maybe console error.
Wait, why didn't it show that error when you oh console info? Okay.
Yeah, exactly. So console info is the other one. Right? You have those are 3 warning levels. And I think you can configure the console object. Like I never do this, so I forget how or if you even do. You can configure the console object to only show you errors, or show you errors and warnings, or show you errors and warnings and infos. So info means this is just letting you know. Warn means this is just letting you know, and then error is you need to know. And console supports all of that. Yeah, I thought you did, and I was baffled.
Oh, okay.
So cool. So what do we think of these? What do we think of these messages?
Doesn't say which part of the object. So which what do we call it? Which post had the error?
Doesn't say which post had the error. Yeah.
Yeah. And we're still displaying these guys.
And we're still displaying these guys. Yeah. Yeah, so there are a couple problems with this. One is it's still a little light on info. Like we don't know which post it was. We don't know who was using the compute post score function. There was a third thing that you said that I forgot. Oh yeah, we're still getting the wrong result.
Yeah, you gotta else it, I think.
Yeah, maybe.
Yeah.
Yeah, we gotta else it. Except we're not gonna else it. We're gonna do like the error handling that I'm about to teach. So yeah, if you didn't have access to error handling language features, you might do this as like an if-else thing, right? If something is wrong, log to the console that something is wrong. Else, do the thing. Keep on going. But we have access to error handling features in JavaScript that we're going to learn about momentarily. And I think I heard someone, I think you mentioned what we're going to do next. We're not going to use if else. We're going to use try catch. Yeah. Actually, first we're going to refactor that console log. So it actually throws an error. Because right now we're not throwing an error, right? This isn't actually an error. This is just some text in the console, right? We want to make it actually throw an error, and I want to demonstrate why that turns out to be better than just logging. Logging is useful, don't get me wrong. But if we throw an error, that's even better. So let's flip back to the code. Let's scroll down to where we're doing our type checking. And I want you to change console log to throw. Space, new, space, capital E, error. Let's give that a run. Cool. What's the difference? As soon as it hit the error, it crashed. Yeah. Yeah. So default error behavior is if nothing handles the error, it's just going to go like up the stack, up the stack, up the stack, looking for someone to handle it. And if nobody does, if it reaches the node parent process, like the process that is node, and nobody's handled this error, it's going to blow up. Right? It's like, you know, it's like this error when you say throw an error, it's like kind of like throwing a ball or throwing a water balloon, right? If it goes over everybody's head and nobody catches it, it's just going to hit the wall and explode, right? It's also kind of like throwing a tantrum. Right? It's like if someone's throwing a tantrum, they're not really they're not really like looking to fix their own problem right now. They're just looking to make a really big deal about the fact that they have a problem. And so, you know, the person that deals with them goes and checks with their manager, and that manager doesn't know what to do, so they go and check with their manager, and that manager doesn't know what to do, so they go check with their manager. Makes it all the way to the CEO. The CEO is like, this is dumb, close the store. Like, why am I dealing with this? So we have ways to intercept that along the way, and that's try catch. But yeah, so it's a cool idea to throw errors like this to say, okay, something has gone wrong and it needs to be handled. And it's also great because it gives us a bunch of info. What did we learn from this that we didn't get from the console log or the console warn or whatever we used? Someone said line number. Where does that come up? Yep. We actually have a bunch of line numbers, right? So what's this thing called? Error log, error stack. Yeah, you might call it the stack trace. Yep. So the stack trace is, you know, the node interpreter is keeping track of, you know, why was I running this line? Oh, because this code asked for it, and it did that because this code asked for it, and it did that because this code asked for it, right? So you can imagine using compute score in several different places. So you see an error like this come up, and you don't know really which thing went wrong. Was this a new post? Was I going through a collection of posts? Was this web or mobile? So the stack trace lets you narrow the scope, narrow the field. What exactly is going wrong? So we see that at the top that this occurred in compute score, right? But we have more info than that, right? So is any of this useful? And if so, how? Are we interested in any of that stuff? Okay, which stuff are we interested in? Because there's some stuff in here that we care a lot about and some stuff that we don't care at all about. Everything down to module, yeah. Maybe like everything down to object anonymous. But yeah, probably everything down to module. And kind of the way to tell that, the way to tell what to care about. In this case, the stack trace is pretty nice. It starts as like at the most proximal, and it goes down to the most general, right? All the way down to, you know, the node interpreter loader, right? But sometimes, especially when you're using libraries and stuff, your stack traces are all like interleaved with, like they dip into node modules and then go into like your bin directory, and then, you know, they're kind of all over the place, and it's hard to tell like, okay, but what did I do wrong? What's wrong with my code, right? So the way to tell what to care about, or one way to tell what to care about, is, do you recognize the file that it's invoking, right? Is that a file you touched, right? And if you look and you only see one place that has a file you touched, then that's where you have to go look. So who thinks stack traces are useful? Everybody who's listening, great. So yeah, now we're going to talk briefly about how to handle these errors. That's how you create an error. That's how you create your own errors. And I'm sure that's what everybody's going to be doing. Like half of your final midterm projects are going to be just like error handling at this point. That's how you create errors. You want them to be descriptive. You want them to be loud. You want the error to occur as soon as it's possible to know that there's a problem. But you don't necessarily want your whole app, you don't want the whole show to stop necessarily just because there was an error. So how do we deal with that, right? So we had the idea of like giving defaults to like upvotes, downvotes. For example, one option is for this to blow up. One option is for this to blow up but then keep going, right? So I want to see the error, but I don't want the app to crash. And the way we do that is by using the error handling tools. So let's flip back to the code. And I think I want to start like wrap all of this in a try block. And a try block looks just like an if block without the predicate. The predicate is the part, the expression that evaluates the true or false, that decides if the if block runs. Yep, exactly. This is the predicate for this if statement. Cool, then we're gonna go space, catch. Yeah, right there. So try catch kind of looks like if else in a way. And the behavior is different but similar. This is flow control, right? And then so after the catch, you're gonna put a paren. Like you're gonna put parens after catch. No, up on line 25 here. And you're gonna put just an E in there. Yeah, and then down here, I'd like you to do a console.error and pass it that E we just created. Yeah. Yeah, looks good. What do you think is going to happen when we run this? Same thing as before, something different? Same thing? Program will exit in a peaceful way instead of just blowing up. Okay, let's give it a try, see what happens. Huh. So it did exit in a peaceful way, but it also blew up. So what gives? The way we did try catch here is basically what we did. If you can flip back to the code for a sec. Thank you. We said try to do this. If anything goes wrong in here, bail and tell me what happened, but then like give control back to the application. Yeah, basically there's like no return value outside of the try. So it hits this error, and then the code down here doesn't run. The rest of the code inside the try block doesn't run, right? But the rest of the code in the script does. It aborts what's going on in here, and then it does whatever's in the catch block, and then it keeps going. So that has a lot of ramifications, right? That means if we're using like a janky API that like 404 sometimes, it gives us bad data sometimes, we can use this catch to handle that. If anything goes wrong, just come talk to this block and it'll figure out what to do, right? In this case, it's just very simply, let me know but don't crash my app, right? And this is a great pattern that can get you in a lot of trouble if you use it too judiciously, right? Like errors are good. We want our app to crash. We want to be disciplined about like seeing errors and going to fix them, right? Instead of just going like, yeah, I don't know why that error comes up, but it's been like 6 months now and nobody's really looked into it. You don't want to be on an app like that, right? That's brittle code. But in practice, in prod, in production code, you don't want your app to catch fire every time someone spills a glass of water, right? What's up?
Question before we had the catch thing, we had on the console, this thing was printed, right? So I'm guessing this was printing to the console. But now that we have console.error, which of these two are actually doing the printing error on console?
Ooh, okay, good question. So before it was this throw new error that was printing the message, right? But in the catch block, we are printing an error, but like where does it come from? So if an error occurs in here, and we catch it here, the error that occurs in the try block becomes this thing. And we can just call this whatever we want, right? We can call it error, we can call it bad thing, we can call it potato. So this error is this error, if that makes sense. Cool. I want to show one more. Sorry, does that answer your question?
Yeah. So if there was no catcher, then it would literally just throw onto console. But if there is catch right there, then it will be captured into the parameter and then console log or whatever you want to do with the error.
Yeah, if there's no catch, it just keeps going up and up and up and up and up, and it reaches the node parent process, and it goes like, why is there an error here, and crashes. Oh, yeah, exactly. So if you just have an empty catch here, yeah, exactly. So if you just delete this console error here and run the code again or comment it out or something, yeah, cool. And run this again. Yeah, like we're throwing an error there, right? But the try catch block is just going. Yeah, it's from before. So I want to show one more try catch thing here. And then we're running a little behind, so we're going to take a quick break after and then switch over to talking about promises. So can we just delete the try catch here? We'll just get rid of that here. Yeah. And no, not the whole thing, okay. just the try catch part. So we want the functionality we had before. So now what we're doing is we're making a decision that if this function fails, if something goes wrong, this function doesn't have an opinion about like what the right way to handle it is. Something else is going to decide. Okay? So like this function is saying if something goes wrong with me, it's not my job to fix it. If you give me bad data, I'm gonna scream, and someone else is gonna have to deal with it. Oh, you're in a different file.
How do you go back one tab?
Shift tab, I think.
Oh, shift tab. Okay.
Yeah. So yeah, now this function doesn't handle its own errors, right? If an error occurs here, it doesn't handle it. Is that a question or a stretch? Stretch, great. So up here, we're going to go to the caller, right? So the caller is going to have an opinion. And we're going to do like a bit of a hack job on this try catch. So try to remember the principles that I was very serious about before, and just imagine that we're doing that here. We're just in a bit of a hurry is all. We want decorate post with score. We're going to make the decision now that if something goes wrong while we're computing scores, we're going to say this is just bad data. I'm not doing this. So we're going to wrap this whole function, like this is basically a one statement function, right? Return post.map, build this thing, right? So we're going to just wrap this whole thing in a try block. I admire your commitment to indentation. Very good, yeah. Yeah, and we're gonna write a very descriptive error message in our imaginations. And here we're just gonna go console error, bad data. But remember those three, what are the three things that a good error message has that this one isn't gonna? Where the error happened, what data was involved. Third thing that I have written down but forgot. Oh yeah, what went wrong? Of course. Yeah, okay, so we'll save, run, and then break time, I promise. Ooh, where does it throw? Yeah, good question. Where does it throw? Yeah, in compute post score, right? So we know compute post score is gonna throw an error, right? In this case, we know. We don't necessarily like know in real life, right? We hope we have good data, but if we don't, we want to know about it, and we don't want to make mistakes about, showing not a number to a user or something. So we want to say this data is bad, somebody fix it, right? So yeah, the error occurs here, and when compute post score doesn't have a plan for handling it, it defers to its caller, right? And this caller does have a plan for handling it. So let's run it, see what happens. Oh yeah, so in this case, we just get the error from the compute post score function. But just go ahead and change console error here. Just pass it this string bad data. So in this case, we just swallow the specific error and we give a more general error, right? So in this case, we made a decision that, okay, the error that compute post score throws is not going to be the right zoom level. It's going to narrow the scope in the wrong way. I want to tell the developer that this is what's wrong, not that the thing in compute post score is wrong, right? And in real life, we would want to say something about like, there's no doubt that this is because bad JSON came in, right? But yeah, the thing that I want you to notice here is that the error was swallowed, and we decided to contextualize it in a different way. And that's basically it. If you guys have other questions about error handling, please ask me. I'm very passionate about it, but not right now. Let's take a break, come back, and we'll do promises. Maybe it kind of depends. I think what you want to happen is, I'm going to go and break real quick. So I think what you want to Cool, guys. I think we'll get started again. So I hope you enjoyed the lecture on errors. Welcome to the lecture on promises. Who's ready for a contrived example? Good. Thank you, two of you. Was that? So we're going to use these two APIs, IPify and IPAPI, and I would probably forget which was which if I didn't have it written down, but I do. So IPify, straightforwardly, so tiny. I send a GET request to this API endpoint, and it gives me back my IP address in JSON. That's handy. And the reason that's useful for me is because once I know my IP address, and this is the best way that I could think of to figure that out in this example, I can use it in here. This IP API endpoint. God, it's going to get confusing. And that'll give me all this detail about what my IP address says about my personality. Just kidding. What it says about like where I'm located and stuff. So it says that I'm in Vancouver, British Columbia. It says my latitude and longitude. This is only 4 decimal places. It's like purposely constrained, so it's not too accurate. But GPS and like geolocation can get way more accurate than that if you let it. So. Yeah, so I want to write an app that goes and asks IPify for this IP address and uses that. You'll notice it's already difficult with one hand. You'll notice that the URL here has the IP address in it, right? So I need to know the IP address already to make this request. And I didn't even bother to check if you can just say, could you use my IP address for this API endpoint? Because I didn't want to. I wanted to do it this way. So what do we know about this problem in general? That I want to write a script that hits the first API, gets a result from it, uses the result of that to hit the second API, and then get the result from that. What do we know about that problem? Like, what's it? Where do we start thinking about that? Let's make a GET request. Yeah, HTTP requests are involved for sure. They're going to be GETs. Sorry? Nested callbacks? Yeah. Yeah, nested callbacks are involved. Why do we need nested callbacks? We need nested callbacks because it's asynchronous. What does asynchronous mean? We're on a roll, guys. I like this. That's true, but that wasn't really an answer to why, like, what makes it asynchronous, right? So you're closer to the mark. The asynchronous part is that JavaScript isn't going to start the request, wait for the result, and then run the next line of code. When we start dealing with asynchrony, JavaScript is an asynchronous language first. And what that means is that it doesn't necessarily run in an imperative way, right? Top to bottom, line by line, right? We're used to thinking of scripts when we first start learning to program as like recipes, right? You know, step 1, do this. Step 2, do this. Step 3, do this, right? You set up all your variables, you declare some functions, and then you like pass the variables into the functions, and then console log your result or something, right? You run it, it goes step, 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 and then exits. Right? But pretty quickly, if what we're trying to learn is how to develop the web, start to notice that that's not really how any of our apps work, right? And it doesn't matter if it's front end or back end. That's not really how either of them work. If it's a back end app, we're running a server, right? So server starts running, it goes like line by line, and then it exits. Except it doesn't exit, does it? In fact, that and then it exits step doesn't occur until we like manually quit it and then just run line by line and do the things in the file thing isn't really a good description of how a server works, right? In a server, we define different behaviors that are kicked off by certain inputs, right? So we have like routes. That's how we do it in Express, right? We say a request is going to come in. The server's going to be listening for a request. When it comes in, you might do this. If the route says this, you're going to do this. If the route says this, you're going to do this. If the route says this, you're going to do this. You're defining all of these different behaviors. And while in the file, there's like one up here, and then the next one below it, and the next one below it, the order that they come in the file isn't really related to the order that they're going to be run or anything like that, right? That like recipe just run top to bottom thing, that imperative style of programming is what we call that, doesn't apply to server code at a high level. Similarly with the front end, what we're doing on the front end is we're building user interfaces, right? We have buttons that are listening for user activity, right? The page loads, and then it waits, right? A bunch of stuff happens when the page loads, and then the user interacts with it. And if the user takes 5 seconds to decide what to click, that's centuries in computer time. And the app is just sitting there waiting to see what happens, and then if the user clicks this button, this thing happens. If they click this button, this thing happens, right? And the order that you define what each button does is unrelated to anything to do with the order that the buttons are going to be clicked in or anything like that, right? You don't look at, oh, there's a click handler up here, and a click handler down here, so that must mean that the user's going to click this button first. There's nothing like that at all, right? You gotta stop thinking about it that way. And that's kind of what asynchrony is in a way. With something like API calls or database calls, asynchrony comes into play as the point where you have this node process running that you're in control of, and you're about to hand off control to some other piece of software, something outside of the node process, right? So in the case of an API call, you're handing off control to the network layer, right? You're saying this procedure, this thing I'm in the middle of, is no longer in my control. I don't know when I'm going to get an answer back. I'm just going to describe what to do when I do get an answer back. When control returns to me, this is what I'm going to do. For a database, it's the same thing, right? So even though in most cases, certainly in all of your cases right now, your database is running on the same machine as your server and your web server, and so the interactions between it are pretty quick, but they're still leaving the node process and going into database driver land, and that differs to database land, right? And then there's this handing off of control, right? And that's what promises help us deal with. They help us deal with an environment, a domain where all of our behaviors have this sort of, you don't necessarily know when things are going to get kicked off. And the order that things come in the file doesn't relate to the order in which they execute. And B, control is being handed off to something else. And then we need to know what to do when we get control back. So that's what promises do. That's also incidentally what nested callbacks do, right? So to what you said about we need nested callbacks because asynchrony. What we're doing is we're like making a function call, and then we're giving a callback to say, look, don't do this right now, but later on, and you know when, later on, this is the behavior that I want, right? Don't do this now, but this is the behavior that I want later. Promises do the same thing, but whereas with nested callbacks, nested is almost like a bad word in that case, right? might become familiar with the waterfall, like with callback hell, right? Where your callbacks get like nested inside of each other, and it's kind of weird that the first thing happens, and then a second thing happens, and the second thing brings with it all the context of the first function, right? And then if there's a third thing that happens, it brings all the context from the second function and all the context from the first function, and it's like it's weird that it's the first function's job to invoke the second function in kind of like a philosophical way that doesn't really like change your life necessarily, but it still seems kind of weird. It's sort of like you order something off Amazon and then the delivery person like puts it in your hand and then tells you to go into your apartment and plug it in. It's like, what? I just want my package, man. I don't need you to tell me to open it and use it. Like, I know to do that. I decided that when I ordered it. So promises break us out of that nesting pattern, and they trade it for a chaining pattern, right? So incidentally, you're going to see that we're still using callbacks. The function that we pass to our .then is still a callback. So you're like, what's the difference? Why isn't this a callback? Well, it is. But what we get out of is this pattern of nesting and nesting and nesting and getting into callback hell and watching the tabs go down the page and disappear off the side. And that makes it pretty easy to change the order that things happen in, and it makes it easy to control the context. So you don't get like a bunch of like, you have 3 or 4 things all called results, and then they like overwrite each other, and it all gets very messy and muddy. Promises don't do that. Promises, they do the thing they're supposed to do, and then they return something, and that return value gets handed off to the next thing in the chain. So what's really nice about that is all promises have the same interface. Once you start a promise chain, everything returned from that promise chain is a promise. Even if it's not. You return a string, doesn't matter, it's a promise. Right? And all promises implement the .then interface. The .then.catch.finally interface. But we're going to talk about .then. .then is how you make promises work, and then the other stuff is like just useful. So we want to find out that a thing is a promise, and then we want to figure out how to interact with it. And I'm hoping that in the next like 15 minutes or something, we're going to be able to get through all that. But for that, I'm going to need someone with 2 arms to come help me. Thank you. Okay, so over here I have a beautiful piece of broken code. This doesn't work, but it kind of sketches out what I want to happen. So I'm using the request library. I'm using the request promise native library, by the way. So one of the things that we're going to try to investigate here is how do we know that we're dealing with a promise? And one way is because there's the word promise up there. That's a good hint. A lot of times you don't have that. But I can promise you that this is going to make a request to this API endpoint. That is going to happen when the script runs, and same thing down here. Sending that, but it's not actually doing anything with it. Yeah, exactly. So what I want to do is kind of like probe at this code. Like imagine you're trying to make this request library work. You have to determine what sort of thing you're dealing with. Like what is this thing? And then we're going to discover that it's a promise. And then knowing that, we're going to figure out how to use it. And if there's time, and if you guys are cool with hanging in there for like a little bit after, like if you're okay with the lecture going a little long, we'll talk about how to chain these 2 requests together. So where we want to get to is we can get this data out. And then where we really want to get to, that's going to be useful, I think, for your midterms, is get this data out and then use it for this. So that we create a dependency chain out of these 2 things. That's the dream. You guys with me? Thank you, one person. Okay, so how do we investigate what this thing is? What might we try? Good first start might be just run the script. So this file is called demo-promises.js. Cool, so I got my console infos. They came out. Nothing happened, right? So I invoke this request function. We're not doing anything with it, right? Maybe we want to see like, okay, what is this request thing? How do we figure that out? Like,
Use a callback to a console of the result, the response of the
we're kind of on the right track for like figuring out how to get the data out of this, but I just want to investigate what this thing is first.
just console of the request of the server.
Yeah, I just want to console log this thing. Let's see what it is. And promises are first class values, which means you can put them in variables. Just like functions, right? That's what it means to be first class. So you can put it in a variable, or you can put it in like an inline expression, and you can pass it around like a value. So promises are that. So we can put it in a variable, or we can just console log it like that, and we can interrogate what it is. That's what we're going to do now. It's so quiet. Hardly noticed you passing through. So holy cow, what's this? This is some huge object, right? Let's scroll through this a little bit. It's got a bunch of metadata in here. Actually has a lot of metadata in here. Yeah. Can you put request in a variable? Console log variable. Because yeah, what I want to show you guys is like, look, this is how you know it's a promise, and that's actually harder to do than I thought with this particular object. Yeah, let's try that. Yeah, maybe just comment these out for now. 13, 14, 15, we can just comment the whole thing out. Yeah, now give that a run, and we'll see what happens. This is really big. I'm actually not sure where like the promise part of this is hiding. I didn't look at this before. Usually I do this with fetch, and fetch is just like, yeah, it's a promise. Would type of work? I don't know. Let's try it. Not helpful. Okay, so you guys are just gonna have to trust me that that's a promise. If you want on your own, you can try this with fetch in like the browser console. Do a fetch request with like, just some URL, console log that, and that'll be like, hi, I'm a promise. But this object doesn't do that. Moving on. So I assert that this is a promise. What's next? Yeah, we know it's a promise, so we know we can stick a dot then on it. Hey, there we go. Promise pending. Why do we get promise pending here? Because every step in a promise chain, everything that comes out of a dot then is a promise. So in this case, this is just empty, right? But it's still a promise. So yeah, I guess in this case, if you suspected that maybe it's a promise, you would call dot then and see if that works. So what goes in dot then? Anything. Well, a function goes in dot then. A function goes in dot then. So I like to use arrow functions. So here we might go result. I like to start with as a parameter. I would write the word result here. Yeah, and then I would try console log result, and we can get rid of this console log because we're no longer interested in what the promise object itself is. We're interested in what comes out of it. Yeah, let's give that a try. Cool, we got it, but there's something that's a little weird, right? What's wrong here? Yeah, it's out of order. This is supposed to happen after the promise returns. But if we flip back to the code, we see that this is not part of the promise chain, so we haven't engraved any guarantee that these things will happen in a particular sequence in this code, right? These are like totally separate events in JavaScript, right? So if we want to guarantee that this happens, then this happens, we have to have them both in the same promise chain, right? Yeah, cool. So we're like blowing through this right now. Does anyone have any questions yet? Is this brand new? You seen this before? Is this like easy mode? Other than doing what? Other than doing await. Yeah, this is the preferred way to do it versus async await, certainly in the Lighthouse curriculum. And part of the reason for that is because async await is secretly using promises. So async await is like super handy for a bunch of things that you might be up to. But if you don't understand promises, you're going to get yourself in over your head with async await. So you got to get the hang of promises first. Otherwise, async await is going to work and work and work, and you're going to be like, I can't believe this is so easy. And then you'll find yourself just like helpless to understand what's going on if you don't get promises. Promises are very versatile. They're very like hands-on. Async await is great for when you have like those nice encapsulation barriers around your functions, and you just say like, I just need to invoke this, and it'll do the right thing, and then I can move on. Async await is great for putting together these dependency chains, for building these synchronous behaviors. I think promises are the right tool. Okay, great. So we got the IP address, right? Now let's add on the next part of the dependency chain. What do we want to do with the IP address? We want to get the IP address itself, right? It's currently, yeah, it's an object that might actually be a JSON string. How do we find out if that's an object or a string? Type of, yeah. We could also try just like result.ip and see if it gets us the thing we want, or if it's like a problem. Undefined, so it looks like it's not a thing. So maybe what's going on is we're looking at a JSON string and my interpreter is sort of lying to us. So how do we turn it into an object so we that piece of data out. We have to parse the JSON. Good. All caps. My caps lock is down to command. Watch for that. Hey, there we go. That looks more like a legit object. Great. So now we can get the IP out of it, right? Sweet. We have the IP address. What do we want to do with it? Yeah, determine the geolocation stuff. So how are we doing that? We're making another request. Yeah, so we're saying I want to make a request, then I want to like do some processing on the result, then I want to use that result to make another request, right? You'll notice that quite naturally the word then came out of my mouth a few times, and that's a good thing to notice when you're putting together a promise chain. So we want to make a request, then process the request, then make another request with the result. Does it go inside or does it go on the end of the function? What's that? Good question. The answer is both are okay. So if you want, I think it's useful to break out your steps into separate .thens, even for parts that aren't necessarily asynchronous, because that makes it easier to like move them around, and, like include and exclude steps, depending on what's going on. But in this case, we're going to use another .then. Yeah, and the function that we pass here is going to receive a parameter. And what's the value of this parameter here? The value of this parameter is going to be what comes out of this .then. What comes out of this function, right? Yeah, very good. So the function wasn't returning anything before, so that means this .then is going to receive undefined. But now we're returning the IP address, right? So all that you can do with the .then is like you can just kind of hand off the ball. You can hand one result in. If you can batch a bunch of results together, you can put them in like an array or object or something and pass them down. But the promise interface is that you can pass one value along, right? So that value is going to be the IP because we return the IP, right? And what are we going to do with the IP? Kick off another request. So you can actually just copy request all the way to there. Yeah, now what? What's that? Oh yeah, I see what you're saying. Because this is called IP, this is called IP address. Yeah, so those need to match. Good spot. Yeah, so now we have a promise inside of a promise. This is starting to feel a little bit like callback hell, right? Promises inside of promises inside of promises. Like, where does it end? Do I put a .then on the inner promise? Starting to feel kind of backed into a corner. No problem. We're going to do something that is Quite simple, but quite magical. I said earlier something about the return value of one of these functions. The return value of one of these functions can only be one thing. It doesn't matter what this says, what this return says. What comes out of the dot then can only be one thing. A promise. Yeah. So if you return IP here and then check what the whole thing is, it's still a promise, right? It's a promise that resolves to this IP address, but it's still a promise, right? So that means that we're treating this like this, and not the other way around. From the perspective of everything outside of this scope, this dot then, whatever comes out of here is a promise, even if it's undefined, even if it's a string, even if it's a promise. So all we have to do to get the result out here is return this promise, and then out here call dot then on it. That's going to blow your mind either like now or in a few weeks or something. But like that's really like the thing you get out of promises. Is you avoid callback hell by just going, you just keep everything at this top level. There's no nesting at all, right? You return this promise, which means you can call dot then here, which means you stay at the same level of nesting. You stay at this chaining level, and you never have to nest. Is that cool? Is that appealing to anybody? Okay, good. I'm seeing some nods. Great. So we've returned this. So just like we returned IP here, we call this IP address, right? And it doesn't matter that these are different. You can call this whatever you want. We're going to pull the results out of here, and that's going to be what this request resolves to. Let's run it and see what happens. We got rate limited. Cool. Well, I think that's a good place to call it. I promise that whole thing worked, and then just the API gave us an error. You're going to encounter this when you're doing things like you're making a write to the database and then another write to the database based on what you inserted, or you want to do like a read from the database and based on the results do a write or something like that. You're going to have this kind of promise chaining. If you're doing something like, you kind of want to avoid this pattern in a lot of cases, but like you might find yourself doing something like go ask who the current user is from the server, get that back, look at that, and then go ask for their posts or something like that, right? That promise chain is going to happen. So keep an eye out for that, for when you have these different asynchronies that are dependent on each other, and think about building them into promise chains instead of nested callbacks. Any questions before we wrap up? That would have worked perfectly and did yesterday. But maybe I was too enthusiastic about trying. Or someone else here is like hitting the same API like 100 times a minute or something. I don't know. So yeah, thank you guys for hanging in there and for all of your arms. They're very useful. I'm here for the rest of the day if you have any questions about errors or promises or anything.